That's good. Oh. So I think you have already seen that one. I will not repeat the probe. I should not repeat it. It's too complicated. Do this. A very long formula. And if you display it in this way, you will see it's easier to interpret it. Let's go back to repeating command. Repeating command normally will not get the best layout of the result. You just display it in a better way than the direct method command, but I think it is the latest layout. So there are also some computations on number theory. And I shall list several of the functions and I shall demonstrate some of them. We have 4 functions to find the integers around x. They are different. The definition of them are different. You can use help command to see what they are. So the first 4 is used to find the integers for x. And this one is used to find rational approximation to a number. For instance, 1.5, it will return 3, 2. The numerator and denominator. 1.5 will return 3, 2. And this is used to find a reminder of the computation. And these 2 are simple. You can find the greatest common divisor and least common multiplier of m and n. Here I say that m and n are integers. If they are not integers, they are transfer functions. You can also do it in the same way. And this one is used to perform factorization of an integer or a polynomial. And this one is used to check whether the number v is a prime number or not. In all these functions, the v or n or v or n can be vectors rather than digits. They can be vectors. If it is a vector, it will check for every component in the vector whether they are prime or not. So I shall demonstrate some of them later. Suppose we have a set of data like this. If you are trying to find the integers around them doing rounding functions, and you can call these functions separately, and you can check whether the results are the same as you expected. You can use help command to see what they are. I will not extend it to you now. What you need to do is to use help round and see what it means. It is rounding to the nearest integer. So you better know how to use the help command. Or even better, you can use doc command. It will open a HTML viewer rather than the plain text. Doc run to get a better result. So this is the first example I want to demonstrate on this part. Just omit this one. So there is a question. There are 2 numbers. What are the greatest common divisor? It is quite difficult. In primary school, I think you have already learned this kind of thing, but it is quite difficult to calculate it for large numbers. So what you need to do is to code GCD function to get the result, then leave the heavy work to Matlab. And least common multiplier, you can use LCM function. And finally, we want to get the factorization form of the least common multiplier. So there are three parts. First, you get GCD, and second, LCM. Third is the factorized LCM. To solve this problem, we first have to convert them into symbolic variables. Otherwise, there might be some errors in the variable computation for large numbers. For small numbers, there it should be okay. But for large numbers, we better use the symbolic computation part. So we can extract n and n, the two numbers. Then we can give the command to find the greatest common divisor and LCM. And then we can, if we find the LCM, we can code function, factor function, to find the factorization of them. So these are the results we obtain. This is the common, which is the common divisor. This is the multiplier, and this is the factorization. It's quite straightforward. We can obtain the result immediately.